In this video, we'll talk about absolute value functions. We define the absolute value function by the rule f of x equals the absolute value of x, which we write vertical bar x vertical bar. This is a piecewise defined function given by the formula f of x equals the absolute value of x, which is x whenever x is non-negative, and the opposite of x if x is negative. The result of the absolute value function is always a non-negative number. That is, it's either positive or it's zero. So if you start with an x, which is already non-negative, you just get the same thing back. However, if x is negative, then you get the opposite of x, which is a positive number. The graph of the absolute value function looks like a V with its vertex at the point 0, 0. To the right of 0, to the right of x equals 0, the graph looks like y equals x, a straight line with slope 1. And to the left of x equals 0, it's also a straight line, but it's y equals the opposite of x, which is a straight line with slope -1. When x is equal to 0, you just get 0 back. You want to think of the absolute value of x as the distance between x and 0. So for example, both 2 and -2 are 2 units away from 0, so the absolute value of both of those is 2. The distance between 0 and 2 is 2. The distance between 0 and -2 is also 2. So that means that the absolute value of -2 is the distance from 0, which is 2, and the absolute value of +2 is the distance away from 0, which is 2 units. One thing that we want to be able to do is solve equations involving absolute values. And for that we rely on this basic fact, which we've called basic fact 1 here. Suppose that c is a positive number. If the absolute value of x is equal to c, then that means x is either equal to c or the opposite of c. So if we were to draw a number line here, like so, and let's put 0 on this number line. If the absolute value of x is equal to c, that means x is c units away from 0. So it's either c units to the right, in which case x is c, or it's c units to the left, in which case x is -c. The absolute value of x is equal to the distance away from 0. So either x is equal to c, or x is equal to the opposite of c. So in example 2, we have that the absolute value of x is equal to 5. That means that either x is equal to 5 or x is equal to -5, because on a number line, the absolute value tells you how far away you are from 0. So if you're 5 units away, you're either 5 units to the right, in which case you're at 5, or you're 5 units to the left, in which case you're -5. So those are the two options. This brings us to basic fact number 2, which is essentially the same as basic fact 1, just slightly altered. So if c is a positive number, and if the absolute value of the function f of x is equal to c, that means the function is either equal to c or -c. So all we've done here is we've replaced x with some function of x. So this function could be x cubed minus 3x plus 4, or something like that. We'll see explicit examples in a moment. To solve an equation involving absolute values, the first thing to do is to isolate the absolute value so that it looks like this. The absolute value of f of x is equal to c. That means that either f of x is equal to c or f of x is equal to -c. Those are the two options. So then you solve for each equation separately, and you'll get some solution for the first one, f at x equals c. That will tell you some values for x. And then you'll get something else for the second one, some other values for x. So you'll have two cases, and you have to solve each one separately. Let's look at an example. So here we're looking at the absolute value of the quantity 2x plus 1, and then from that absolute value we're subtracting 7 and saying that that must be equal 0. So we want to solve this for x. So in this particular case, this 2x plus 1 is what I was calling f at x before. So the first thing to do is to isolate the absolute value of f at x is equal to c. So in this particular case, c is going to equal 7. So we're just going to add this 7 to both sides, and then we'll have the absolute value of 2x plus 1 is equal to 7. Maybe I'll make my 1 look like this so it doesn't look like the vertical bar of the absolute value sign. So we've just added 7 to both sides. So now you can see that in this case, c is equal to 7. So we're going to break this up into two cases. So either 2x plus 1 is equal to 7, or the other option is that 2x plus 1 is equal to the opposite of 7. So remember that the absolute value is measuring the distance from 0. So this quantity 2x plus 1, the distance away from 0 is 7. So if it's 7 units to the right of 0, that means it's equal to 7. But if 2x plus 1 is 7 units to the left of 0, then 2x plus 1 is the opposite of 7, or negative 7. So we have to solve each one of these individually. So solve each equation. There are two of them, so we'll end up with a solution for each one. So let's start on the left. So 2x plus 1 equals 7. Subtract 1 from each side. 2x equals 6. Divide by 2. X equals 3. So that's one solution. But we have another equation. So on this right equation, we're going to again subtract 1 from each side, but now it's 2x equals negative 7 minus 1, which is negative 8. Once again we divide by 2, and then we have x is equal to negative 4. So those are our solutions, x equals 3 and x equals negative 4. Just for fun, let's do another example. This one's a little bit more complicated. Let me just rewrite it. 3 equals 4 times the absolute value of 2x minus 1 minus 9. So again, I'm making my 1 look like this so it doesn't look like the vertical bar for the absolute value. So the first thing to do is to isolate the absolute value. So we want to isolate this quantity right here. This quantity. We want to isolate the absolute value. So the first thing we do is we add the 9 to both sides. So then we have 12 equals 4 times 2x minus 1. Now we divide both sides by 4, and now we have 12 divided by 4 is 3 equals the absolute value of 2x plus 1. So we've managed to isolate our absolute value. Let's just rewrite it so it's on the other side. So let's swap these two. The absolute value of 2x, that's supposed to be a 2, 2x minus 1 is equal to 3. So that tells us that either 2x minus 1 is equal to 3, or 2x minus 1 is equal to the opposite of 3. So 2x minus 1, remember the absolute value signs tell you the distance away from 0. So if 2x minus 1 is 3 units to the right of 0, then 2x minus 1 is equal to 3. But if 2x minus 1 is 3 units to the left from 0, then that means 2x minus 1 is equal to negative 3. Now we want to solve both of these individually. So the first one, the one on the left, we add 1 to both sides, and then we have 2x is equal to 4, and divide both sides by 2, and you get x is equal to 2. Now, for the second equation, again, we start off by adding 1 to both sides. But now we have 2x is equal to negative 3 plus 1 is negative 2. Once again, you divide by 2, and now you have x is equal to negative 1. So those are our solutions. X equals 2, and x equals negative 1. Here's another basic fact. If the absolute value of a quantity is equal to 0, then it must be true that that quantity is equal to 0. Because the absolute value, again, it tells you the distance away from 0. So if the distance of this quantity from 0 is 0, the only way the distance of something can be 0, the only way the distance away from 0 can be 0, is if it was 0 to begin with. So if the absolute value of f at x is equal to 0, then f at x must be equal to 0. So that comes up when you're solving an equation like the one you see here. 6 is equal to the absolute value of 4x plus 3, that quantity in absolute value, plus 6. So if we subtracted 6 from both sides in order to isolate the absolute value, you're going to end up with 0 is equal to the absolute value of 4x plus 3. So here, we're saying that the absolute value of 4x plus 3 is equal to 0. The only way that can happen is if the thing inside the absolute value was 0. So 4x plus 3 equals 0. And now we solve for x. You subtract 3 from both sides, you get 4x is equal to negative 3. Now divide by 4, and you get that x is equal to negative 3/4. If the absolute value of a quantity is equal to 0, you only get one option. It's not like the previous equations where the distance away from 0 was some positive number, which meant you could either go to the right by a certain amount or the left by a certain amount, and you end up with two solutions. Here you're saying that you're not to the right or left of 0, you're saying you're actually at 0. So that means you only get one equation. So if 4x plus 3 in absolute value is equal to 0, that means 4x plus 3 must be identically equal to 0. So that means you only have one equation, so you'll end up with one solution. Let's do another example. So again, we have 2 equals the absolute value of x plus 1 plus 7. So the first thing we want to do is we want to isolate the absolute value term. So we want to subtract 7 from both sides. So on the left, we have 2 minus 7, which is a negative 5. And that's equal to the absolute value of x plus 1. So if I rewrite this so the absolute value is on the left, we have the absolute value of x plus 1 is equal to negative 5. Now this is impossible. So this is not possible. The absolute value gives you the distance away from 0. It's not possible for a distance to be negative. So it's not possible for the absolute value of x plus 1 to be negative 5. The absolute value function always gives you something which is non-negative. It's either positive or 0. But this is negative. So this isn't possible. That means there is no solution. There are no values of x for which the absolute value of x plus 1 is equal to negative 5. And we've written that here as basic fact 4. The absolute value of the quantity f at x cannot be negative. So if c is a positive number, then this equation, the absolute value of f at x is equal to a negative number, has no solution. The next thing we want to do is talk about solving for inequalities. For example, solve the absolute value of x less than or equal to 6 for x. So what is this telling us? The absolute value of x is the distance away from 0. So here we're looking at we're looking for x values so that the distance away from 0 is 6. Well, let's draw a number line, like so. And here's 0. So we want to look for all numbers x that the distance away from 0 is 6 or less. Well, if we're moving to the right of 0, then we can go all the way out to 6, like so. Any number between 0 and 6 will have distance less than 6. Similarly, on the left, you can go out to -6. It's a little bit too far, maybe. Let's say right here. So all of the numbers between 0 and 6, including 6, have distance less than or equal to 6. And all of the numbers between 0 and -6, these all also have distance away from 0 equal to -6. So the numbers that we're interested in are these numbers. All of the numbers between -6 and 6. We're also interested in the numbers whose distance is actually equal to 6. So this inequality is all x such that the absolute value of x is less than or equal to 6. Well, if it's equal to 6, that means it's on these endpoints. So the way we indicate that we're including the endpoints is we put a circle like so. Now it's going to be a filled circle. So we put a circle and fill it in. So if you fill in the circle, that means you're including 6 and -6. If I wasn't going to include 6 and -6, then I would leave those circles empty. Let's actually write that down. So if the inequality was the absolute value of x strictly less than 6, then we would write, then our solutions would be all of the numbers between -6 and 6, but not including the endpoints. So in that case, you'd draw an open circle like this. You wouldn't fill it in. And then we draw a line here to connect these two. So another way to write these inequalities, so this first one here, the absolute value of x less than or equal to 6, this is the same as saying that -6 is less than or equal to x is less than or equal to 6. So it's all of the numbers between -6 and 6, including the endpoints. So in interval notation, this would be the closed interval from -6 to 6. Whereas the second one here, this is -6 strictly less than x, strictly less than 6. So this is the open interval where we don't include the endpoints. So this is what we have when we're looking at the absolute value of x is strictly less than or equal to 6. Well, less than or equal to 6. So if it's the absolute value of x is less than or equal to 6, that means you're looking at all of the numbers that have a distance away from 0 less than or equal to 6. So that means you're including 0, and you want the points that are in some sense close to 0. So you're looking at numbers around 0, because you're looking for x values where their size is small. Well, less than or equal to 6. So in our next example, we'll look at the opposite. So in this example, we're looking for all x's where their size are bigger than or equal to 6. So that means we don't include 0. We're looking at large values because the large values are far away from 6. So in terms of a number line, here's 0, and here's 6, and here's -6, just like before. But now we're interested in things that are larger than 6 in size. So that's everything beyond 6. So let's do it this way like we did before. So that's everything beyond. It's also everything smaller than -6. We draw little arrows at the end to indicate that it's going to continue out. So like so. We draw little arrowheads. So everything out here is farther away from 0 than 6. But everything out here is also farther away from 0 than 6 units. So everything to the left of -6 is farther away from 0 than 6 units. So this distance, this is 6 units in length. Over here too, this is 6 units in length. Now notice that once again, we're looking at an inequality that's greater than or equal to. So that means we include the endpoints. That means we include those numbers that are exactly 6 units away from 0. So again, you indicate that using a circle which is filled in. So in this case, we're looking at x, which is greater than or equal to 6, or x is less than or equal to -6. So that's how you write it. In interval notation, this would be -infinity to -6, or 6 to infinity. Now it's important to understand that this is an or and not an and. Why is that? Because it's both of the intervals. We're looking at this interval and we're also looking at this interval. The reason it's or is that we're looking for x's that satisfy this inequality. So we're looking for any x such that the absolute value of x is greater than or equal to 6. That is, we're looking for any x such that the distance away from 0 is greater than or equal to 6 units. So that means x can be in this interval, or it can be in this interval. It's in this interval or this interval. So x is either greater than or equal to 6, or x can be less than or equal to -6. Either one of these conditions is okay. So if it's this condition or it's this condition, you have a solution to this inequality. Once again, if we leave out if we use a strict inequality instead of a greater than or equal to, so if we write, so if we have the absolute value of x is strictly greater than 6, then we have the same thing, but we just exclude the endpoints. So that's a little too long. Let's try that again. So let's do it like this. So here's 0. That's supposed to be a 0. Here's -6. Here's +6. And so now we're just going to not include the endpoints, like so. Just leave the circles unfilled. So in this case, it's x is strictly greater than 6, or x is strictly less than -6. So in interval notation, you just leave off, so it's -infinity to -6, so you just use open intervals. And now at this moment, I suddenly realized I had open intervals on the first one, but those are supposed to be closed because you're including the endpoints. I just didn't notice that I did that until just now. Okay. So here we're including the endpoints. Here we're excluding them. So what's our method for solving inequalities? So to find intervals that satisfy an inequality that looks like this, either the absolute value of f of x is less than or equal to c, or the absolute value of f of x is greater than or equal to c, the key step is to look at not the inequality, but to look at equality. So you start by solving the equality, the absolute value of f of x is equal to c. That's what we started out doing. Now this will identify the endpoints of the intervals. And once you have the endpoints of the intervals, what you want to do is on a number line, mark those endpoints. We'll use filled circles in this case because we're looking at less than or equal to or greater than or equal to. So that means we're going to include the endpoints in whatever intervals we come up with. Now what will happen is you'll have divided the number line up into a bunch of intervals. So test one number in each interval to see if the inequality is true on that interval. If the inequality is true on that interval, then the interval is included. And so draw a line connecting the endpoints to show it is included. Just make it darker than the number line so you can see it. if you're looking at strict inequalities instead of less than or equal to, greater than or equal to, so if you're looking at strict inequalities, then replace the filled circles with empty circles to indicate that you're not including the endpoints. So let's look at some examples. So here's our first example. The absolute value x minus 5, the quantity x minus 5 in absolute value is less than or equal to 3. So in this case, we're going to include the endpoints because it's less than or equal to. So step 1 is to solve the equality. The absolute value of x minus 5 is equal to 3. Now here we have an equality involving absolute values, so we isolate the absolute value, which has already happened, it's already isolated, and then we break it apart into two separate equations. Either x minus 5 is equal to 3, or x minus 5 is equal to the opposite of 3. So remember, this is telling us that the distance between 0 and x minus 5 is equal to 3. So either x minus 5 is 3 itself, or it's the opposite of 3. Okay, so now we solve each one of these individually. So for the first one, we add 5 to both sides, and we get x equals 3. For the second one, well, we still add 5 to both sides, but now we end up with x equals negative 3 plus 5 is 2. So 3 plus 5 is 8. I think I just wrote down the wrong thing there. So that tells us our endpoints are 8 and 2. So on a number line, so this is step 2, on a number line, mark the endpoints. So step 2, we draw a number line like so, and just put the endpoints. So one of them is 2, and the other is 8. Now what you can see is that this divides our number line into 3 intervals. So you just have to check each one individually to see if it's included or not. And the way you do that is you just pick one number in each interval and plug it into the original inequality. If the original inequality is true for that number, then you include that interval. So that's step 3. Let's do it over here. Step 3. Let me just divide this like so. Okay, so for step 3, we just test one number in each interval. So what we can do is we want to pick something to the left of 2. So a good example would be x equals 0. So then you just plug that into here. So our inequality is the absolute value of x minus 5 is less than or equal to 3. So is the distance between x minus 5 and 0 equal to 3 if x is equal to 0? Well, you just plug that right into there. So you get the absolute value of 0 minus 5 is equal to 3. But that's the absolute value of negative 5, which is 5. So 5 is not, this is not equal to, it's less than or equal to 3. However, so we want to know, is that true? However, 5 is certainly, that is false. That is false. So that means we don't include, don't include that interval. Because 0 is a number in this interval, which makes this inequality false. That should be less than or equal to, but it's still false anyway. We don't have to worry about the equalities so much because the equalities are 2 and 8. Now we're definitely going to include those, so I should have made those filled circles like so, like that. So we plug in any number to the left of 2 into the original inequality. So we just pick x equals 0 because that's convenient. If you plug in x equals 0, you're going to get 0 minus 5, which is negative 5. The absolute value of negative 5 is 5, and it's not true that this is less than or equal to 3. That statement is false. So that means we don't include this interval. Okay, well, what about the next interval between 2 and 8? So you can pick anything that you want. So let's pick something convenient, and let's just say x equals 3. Because that's between 2 and 8. So now we just plug x equals 3, plug into, so to speak, the inequality and see if it's true. Is that true? So 3 minus 5 in absolute value, is that less than or equal to 3? Well, 3 minus 5 is negative 2. So the absolute value of negative 2 is 2, and 2, yes indeed, is less than or equal to 3. So this is true. So that means we do include this interval. Now there's one interval left, which is the interval to the right of 8. So we can just pick anything that we want. Pick x equals 10, and then we plug that into the inequality. So we've got 10 minus 5 less than or equal to 3. Well, 10 minus 5 is 5. So the absolute value of 5 is equal to 5. Is that less than or equal to 3? No, that's false. So that means we don't include this interval either. So don't include this interval. So the only interval we include is this one. So what we're going to do is we're going to draw a line connecting them. So let me just do it like that. So we include the endpoints, and we include every number in between. So our answer, if we write it in interval notation, is the closed interval from 2 to 8, like so. That's our answer. Let's do another example. So again, step 1 is to replace inequality with equality. So we're going to start with the absolute value of 2x minus 3 is equal to 7. So this gives us two possibilities. Either 2x minus 3 is equal to 7, or 2x minus 3 is equal to the opposite of 7. So this gives us two equations we have to solve individually. So in both cases, we add 3 to both sides, and we have 2x is equal to 10. Divide by 2, you get x is equal to 5. That's on the left. For the one on the right, again, we add 3. So then you'll have 2x equals negative 7 plus 3 is negative 4. And then divide by 2, and you get that x is equal to negative 2. So those are the endpoints of our interval. So we're going to draw a number line. Let me just put it over here this time in the upper right. And I'm going to put negative 2 here, and I'm going to put 5 here. It doesn't really matter where they go on the number line as long as 5 is to the right of negative 2. Okay, so now we need to just check. We need to check each one of these intervals. So check intervals. So step one is we replace inequality with equality. Step 2 is we draw the number line. I'm not going to put a step, well, I guess I can write step 2 here. I don't want to have too many numbers floating around that to confuse anything up there. And then step 3 is check intervals. So again, we're just going to pick any number to the left of negative 2, any number between negative 2 and 5, and any number greater than 5. Now notice this is greater than or equal to, so that means we're including the endpoints. We're going to include the endpoints like so. Okay, so now we want to just check the interval. So check something to the left of negative 2. So pick x equals negative 3, just as an example. So now we plug that into 2x minus 3, and the question is this going to be greater than or equal to 7? That's the question. So the absolute value of 2 times negative 3 minus 3. We want to know if that's bigger than or equal to 7. So 2 times negative 3 is negative 6 minus 3. Now that's the absolute value of negative 9, which is equal to 9. And is that greater than or equal to 7? Yes, true. So that means we include this interval. Okay. Now let's pick a number between negative 2 and 5. So now we pick x equals 0. 0 is always very convenient, and it's between -2 and 5. So now again, we want to check 2x minus 3 greater than or equal to 7. Is that true? So that's 2 times 0 minus 3, and we want to know if this is greater than or equal to 7. 2 times 0 is 0, so this is just the absolute value of -3, which is 3. 3 greater than or equal to 7 is false. So that means we don't include this interval. So we include the one to the left of -2, we exclude the one between -2 and 5, and now we just need to check the one to the right of 5. So we just pick anything. Pick x equals 10, just for fun. So again, we want to plug this into 2x minus 3, and is that bigger than or equal to 7? That's the question. Is it bigger than or equal to 7? So the absolute value of 2 times 10 minus 3, that's the absolute value of 20 minus 3. Well, 20 minus 3 is 17, so the absolute value of 17. And indeed, 17 is greater than or equal to 7. So that's true. So that means we include the interval to the right of 5, like so. Now, if we want to write our answer in interval notation, it would be -infinity to -2, including -2, union 5 to infinity, including 5. Remember, you don't include infinity or -infinity because those aren't real numbers. But you do include these two endpoints. You include these two endpoints because you have equality at the endpoints, and we're looking at greater than or equal to. So that's our answer. Let's do another example. This is a strict inequality. That means don't include the endpoints, exclude the endpoints. But you still do the problem basically the same way, you just don't include the endpoints. Okay, so step 1 is to replace inequality with equality. 4x plus 1 equals 2. Okay, so if you have a quantity in absolute value that equals 2, then either that quantity, it's equal to 2, or it's equal to the opposite of 2. So you solve each one of these individually. So let's look at the one on the left. You subtract 1 from both sides, and you get 4x equals 2 minus 1 is 1. So x is equal to 1/4. Now on the right, you get 4x equals -2 minus 1 is -3. So x equals -3/4. Okay. All right, so maybe I'll leave them in the order this way. So I'll put the number line here, like so. So in this case, we have a negative number, which is -3/4, and we have a positive number, which is 1/4. And again, it doesn't really matter where you put them on here as long as the larger number is to the right of the smaller number. Now, this is a strict inequality, so we exclude the endpoints. So we have an open circle for each of them, a non-filled in circle. And now you just have to check the intervals. So step 3 is to check the intervals. So let's pick the one in, it's always convenient to pick x equals 0 if you can. See, here I have a positive or a negative number and here a positive number. So this interval in the middle has 0. So it's very convenient to just pick x equals 0. Because now I look at the inequality, so I want to check this inequality, the absolute value of 4x plus 1. So the question is that less than 2? That's the question. So you plug in the 0, so you get 4 times 0 plus 1 in absolute value. Well, 4 times 0 is 0, so it's just the absolute value of 1, which is 1, which is indeed less than 2. That's true. So that means we include the interval between 3 negative 3/4 and positive 1/4. Okay. Now what we're going to find is we're not going to be able to include the other two intervals, but we need to check them just in case. Okay, so let's pick something to the left of negative 3/4. Well, let's just pick negative 1. I can pick anything that I want to the left of negative 3/4. Well, negative 1 is, and that's a convenient number. So 4 times x plus 1. Is that less than 2? That's the question. Is that less than 2? Now you can sort of see what I was talking about. My 1 here looks an awful lot like that absolute value sign, so maybe we'll just put it like that again. Okay, this is also a 1 here. This is an absolute value sign, and this is an absolute value sign. Okay, so let me just fix this one here. This is a 1, and this is also a 1. Okay, well 4 times negative 1 is negative 4. So we're looking at the absolute value of negative 4 plus 1, which is negative 3. The absolute value of negative 3, which is 3. Is that less than 2? And no, it's not. So we don't need that question mark there. This is false. So that means we don't include this interval. Well, what about the interval to the right? So you just pick anything. You pick anything bigger than 1/4. So pick x equals 1. That's bigger than 1/4. So then it's going to be 4 times positive 1 plus 1. So is that less than 2? And the answer is no, because this is going to be the absolute value of 5, which is 5, and less than 2, that's false. So you don't include this interval. So you only include the middle interval between negative 3/4 and 1/4, but you don't include the endpoints because this is a strict inequality. So that means our answer in interval notation is going to be the interval from minus 3/4 to 1/4, not including the endpoints. All right, let's do another example. Here we go. The absolute value of 1 minus x, that quantity 1 minus x, the absolute value greater than 7. So we do this in exactly the same way. So you start by replacing inequality with equality. So you're going to have the absolute value of 1 minus x is greater than, no, we're replacing inequality with equality, like so. All right, so we have some quantity and its distance away from 0 is 7. So that means it's either 7 or negative 7. So 1 minus x is either equal to 7 or 1 minus x is equal to negative 7, like so. So now we solve each one of these for x. Let's start on the left. The first thing we do is we subtract 1. So that means we're going to have negative x is equal to 7 minus 1, which is 6. Now we've got to solve for x, so you run a negative sign through it. Divide by negative 1, and you'll end up with x is equal to negative 6. Or the other option, again, we subtract 1 from both sides, and we'll have negative x is equal to negative 8. So that means x is equal to 8. So on a number line, we have negative 6 and positive 8, like so. And again, we're excluding the endpoints because this is a strict inequality. So we're going to exclude those endpoints. But now we just have to pick one point in each interval. So what's a convenient number? Let's look at numbers to the left of negative 6. So we can pick any number we want. So let's just pick x equals, I like multiples of 10. So pick x equals negative 10. That's over here somewhere. So just check 1 minus x, is that greater than 7? That's the question. So we're just going to take that negative 10 and plug it in here. So it's going to be the absolute value of 1 minus negative 10, like so. Well, 1 minus a negative 10, minus a minus is a plus. So minus a minus is a plus. So that's the absolute value of 1 plus 10, which is the absolute value of 11. So that's 11, which indeed is greater than 7. So that's true. So that means we include the interval to the left of negative 6. So we include this interval. What about the interval between negative 6 and 8? So now we pick x equals 0 if you can. If you can pick x equals 0, usually you want to pick it. That just makes computations easier. And 0 is between negative 6 and 8. So now we look at the inequality. 1 minus x, is this greater than 7 is the question. And so there's the absolute value of 1 minus 0. Well, 1 minus 0 is 1, so this is just 1. Is that greater than 7? And no, of course not. That's false. So we don't include the middle interval. What about the interval on the right? So on the right, we pick any number bigger than 8. So like I said, I like multiples of 10. Just whatever number is convenient. So we want to ask, is 1 minus x, is this greater than 7? That's our question. We want to know if it satisfies this inequality we started with. 1 minus x in absolute value greater than 7. Now this is supposed to be a 7. It kind of looked like a 7, but there we go. Now in this case, x is equal to 10. So we're going to have the absolute value. We're going to have the absolute value of 1 minus 10. And that's the absolute value of negative 9, which is, of course, is 9. Is 9 bigger than 7? Yes, true. So that means we want to include this interval as well, like so. So we want to include this one, and we want to include that one. But we exclude the one in the middle. So our answer in interval notation would be the interval from minus infinity to negative 6, union 8 to infinity. Again, we're using parentheses here because we're excluding the endpoints. So that's our answer for this example.